want to commend you for volunteering and doing this. So I just want to give some acknowledgement. Anaya, she wrote in the chat, she was in agreement with Aja about going back into the classroom. All right, everybody, I'm gonna put the screen back up that I had. And just before I start, though, there's another teacher here, Miss Williams. Miss Williams, you want to introduce yourself?
Hi, I'm Mrs. Williams. I teach at Renaissance High School. So I'm happy to be here this Saturday, and we'll see how this works out.
All right, so you've seen Aja?
No, I don't think so. But Aja may have seen me, but...
Yeah.
I definitely have seen you walking. I definitely have.
All right. Okay, good. All right, I'm going to put the screen back up. And so just to recap, my scenario here is I'm trying to buy some tile. And so I need to know how much tile I need to buy. I need to know the floor area. And so in measuring the kitchen, and again, we know rooms in real life are not rectangle shaped, but let's say I measured everything and I was able to make a rectangle shape. And so in my rectangle here, my length, which is across the top and across the bottom, is 20 feet. And my width along the sides, 30 feet. Now, of course, I didn't draw this correctly. My width should be longer, right? But let's just go with the numbers here. So I'm just going to ask, if my length is 20 feet and my width is 30 feet, can anybody just tell me how I would find mathematically the area of this rectangle? Curtis, Fatima, anybody know?
You multiply length times width.
Yeah, gotta multiply the length times the width. So, of course, if we do that, we're gonna have 20 times 30. And of course, that will be 600. And since this is two dimensions, length and width, we're going to put a little 2 at the top. It's 600 square feet. And so in this lesson, this next worksheet that you see, I would like you to sort of keep in mind that we multiplied the length, and the length is, let's say, on my diagram, it's horizontal on the diagram. And my width on my rectangle is up and down, vertical. So I'd like you to kind of keep that in mind when we look at this problem. And Anaya, are you with us? Let me make sure.
Mr. Stone.
With us, Anaya? All right.
Hey, Mr. Stone, can I interject something here?
Yes.
A question for the three of you, if you don't mind. Have you had experience working with what most of us refer to as algebra tiles, whether it's the actual manipulatives, the tiles themselves, or online using algebra tiles? Just go ahead and respond when you're able.
Okay, Anaya said she did.
Yes,
online.
I've used it.
Okay.
What is it? What is the algebra tiles?
Yeah, so they're small manipulatives that you can build and construct geometric figures width, and the tiles themselves are a variety of different dimensions, but they're all of them are rectangular.
And usually it's practiced with sort of connected with multiplying the size of a rectangle, a shape of a rectangle, multiplying. And so, like what we have here, we got a rectangle shape, and what would happen is Mr. Tucci would give out a lot of tiles, and they might represent the numbers 1. And so we might have 20 of them going across.
Yeah, I don't know if I can interject here I think Fatima was asking, right?
Yeah.
Yeah, Fatima, so they're plastic shapes. They're made out of they're manipulative. So you use them and you have a piece of paper in front of you. You want to build like a certain usually rectangular shapes with this. So one of the pieces is like so it's like 10 by 10. I think it's 100. So it's they're showing it there. So you have the 1 unit, she's 1 by 1, and then you have, I think there's one of them that like we use for X, and one of them we use for Y. So you really have to have it in your hand to really be familiarized with it. So I suggest, I think if you can Google it, you can probably see what it would look like in real life that we would use. So if you put algebra tiles in real life and as a mathematical, like manipulative, I think you may actually see it there, so you can see better. But what we're doing here, I think we're simulating that in because we don't have them right here. And maybe, I don't know if Mr. Stone has any, I used to have them in my house. I don't know where they are, but we could have shown you that. But we're simulating them in here. So we're trying to show you how we would use them if we had them, if you were with us in the classroom. Usually the algebra one teachers use them more often than the geometry or the algebra 2 or the seniors, or for seniors. Okay, thank you.
I got it. Thank you.
So we're kind of going to demonstrate them online for you. So when we go to the next slide, they got a little representation for them.
Yeah. And, ladies, math is always applied to real life situations. So we got a real situation here of a measuring floor tile. And Mr. Tucci would like to talk about, a lot of times when you buy floor tiles, sometimes it's very delicate. It's the expensive type that looks good, but it's delicate. And so, Mr. Tucci, we got 600 tiles that we need, but
so when you're in for you, when you ultimately are redecorating or whatever at some point in your life, and you're going to be purchasing these materials to in this case to retile your kitchen floor, you're going to go to a store like, for example, Home Depot, and you pick out your tiles, and you purchase the tiles, and you have the dimensions, and you see the on the screen, you get the dimensions of the kitchen floor, and you've got the square footage there, but you may need to, or in most cases you should, purchase additional tiles as well, so to account for the possibility of breakage, to account for the possibility of making a wrong cut, that sort of thing. So you have not only the square footage of the room, but you also should include some additional, a couple of additional tiles to go along with that.
Mm-hmm. All right, so we would like you to keep in mind, just to recap, keep in mind my horizontal, which is length, and my vertical, my width, which is vertical. And that what Mr. Tucci just mentioned, extra tiles. Now this worksheet is going to show some tiles, and they're in a pattern. And so if you kind of follow along.
I'd like to ask them, can they see it? Can they really see the questions, or do we need to make it any bigger? Like, because
So you all have access to you all have access to the tile pattern problem?
We can see the screen.
You can see the screen? Okay.
Okay. But students, are you able to
Yes.
write on it?
Curtis, did I hear you say yes?
do they have the Jamboard, you guys, or what?
You have the Jamboard?
No, if you want them to write on it, you have to send it to them.
I'm not able to write on it, but I can see it.
You're not able to write on it? You can see it?
I can't get Jamboard on my phone.
Okay. Are you able to see?
Download the app, and I'm not downloading the app onto the phone. I don't know why I have to download the app.
So, a suggestion. I mean, if you can just grab a piece of paper and pencil and see, because it's not I don't think it's that big to look at these things. So get a piece of paper and pencil and see what you think about these questions. And you can always put stuff in the chat, I think, in terms of what you think the pattern is or whatever. You could put those in the chat if you're not able to write on this thing. But I would definitely grab a piece of paper so you can jot your ideas or what you think, the equation is or whatever, or you may think about. So I always tell my students, even when they work in Khan Academy, they very seldom have a piece of paper and pencil. I don't know how they do the problems. I'm always questioning. You can't do it all in your brain. So if you're not able to write on here, it's okay to get a piece of paper and pencil and do that. Thank you.
So hopefully some of you will be able to write on it, because if you look at your Jamboard on the left side, there's a pen. And if you click on the pen, you'll be able to use it to write on the Jamboard. So now keep in mind what Mr. Stone said about the horizontal and the vertical, and also about the extra tiles that you may have to buy for the floor. So when you look at figure number 1, do you see any rectangular shapes or any type of shape in figure 1?
Well, before we get into it, this is a lesson where we have figure 1, and these are representing some tiles. Figure 2, there's a few more tiles than figure 1. And in figure 3, there's a few more tiles. You may remember seeing a pattern with squares like this. So a lot of times you want to pick up the pattern, and then you want to come up with a mathematical expression that, in the event that the teacher asks you to tell how many tiles are in figure 10, you won't have to just keep adding. You can just use your formula that you create and come up with the answer. So looking at these figures, can you recognize, let's say, how many tiles are in figure 1 and what's happening when it goes to figure 2 and figure 3? And Anaya, we're not forgetting about you, so you can write this in the chat, and we'll respond to you also. So let's call on a few people. Fatima, how many tiles are in figure? How many tiles are in figure 1?
8.
Yeah, there's 8 tiles in figure 1. So I'm just gonna write a big 8 right here. And Curtis, what about figure 2? How many tiles are in figure 2?
14.
All right, so I'm gonna write a big 14 here. So we got on figure 1 we got 6 squares, 6 tiles, and then we got these 2, so that's 8. And on figure 2, we got let's see, 3 there.
Fatima, your hand is up. Are you trying to say something?
No. Sorry.
All right.
But as I asked, I think what Miss Williams was asking, I think, is also a good way for them to think about this. So, what were you asking, Miss Williams?
Right after you write the next number for figure 3, and I was going to say, do you see any type of shape, horizontal or vertical shape, in any of these tiles?
Well, let me ask this question, everybody. Do you see a pattern? Can you pick up a pattern? There's actually 22 tiles in figure 3. Do you see a pattern that would help you if I were to ask you how many tiles are in figure 20? What pattern do you notice here? Like Aja, what do you notice? It's 8 tiles in figure 1, and then there's 14 in figure 2, and figure 3 has 22. What do you notice mathematically?
From figure 1 to figure 2 is increasing by 6, and then from figure 2 to figure 3 is increasing by 8. So I think that they're each increasing by some form of multiple of 2. So maybe the next one will be increasing by 10, and the next one 12, and then the next one 14.
Hey, Curtis, do you agree with that?
So, if I want to, can I piggyback on her? So, can you draw the next shape and see if that's true? Try kind of sketch real fast in your paper that I asked you to do and tell us what would that be? Would that be 32? Because you're saying plus 10, right? So, would that be 32?
Okay, hold on. Give me a minute.
Okay, that's fine. Take your minute. Any one of you can draw on it or no? You got it. Because you can always show us on the camera what you got, or put it in. Take a picture of it, put it in the chat, and we can always see it.
You can't draw on it?
I don't think they can. That's why I said they can do, some whatever jotting, they can do it in paper and pencil. And then they can
I'm doing it in the paper.
That's fine. That's good. Old
Okay.
school. I love old school.
So if you can't draw on it, Kiera or whoever sent them the Jamboard, if you could click on the Jamboard and change it from editor to, you go to your share screen and change it.
Yeah, and to help you out, you guys, the horizontal, by how much is it increasing? You all notice, do you all notice there is extra pieces on the left and right to the right?
Yes.
Right,
Yes.
so when you're talking about the horizontal, how are they increasing? So you got 2, you got 3, the next one is 4. So what would be this next one that you're trying to draw?
5.
5, good job. What about the length, the width? I mean, the other
6.
So
6.
it's going to be 6. So it's going to be 5 by 6, correct? So what's 5
Yes,
times?
and I'm done.
Right. So
30.
what's 5 times 6?
30.
30, and then you have the 2 pieces on the sides.
32.
Very good. So you already did it. So it doesn't really take that long to even jot on paper and pencil. I just kind of did it myself. Let me try to. I'm going to try to show the camera here. Yeah. For me, that I don't know how much that showed, but that's what I got when I did it in paper and pencil. So a lot of time is even faster than the technology. I don't know if you kind of have an idea.
Are you holding it up? Let me.
Okay. I don't know. I'm holding it up a little.
All right.
Right. So.
Does yours look like that, Fatima and Aja?
Yes.
Oh, there's Fatima's in the chat there.
She
Yeah.
put it in the chat, right? That's what I sometimes ask my students to do, when I'm teaching virtually. They put a lot in the chat for us.
Yeah, very nice, very nice.
So 32. So I guess that, prediction is correct.
So let me ask this, everybody. Would you be able to come up with a mathematical expression that might you could use? And if I asked you how many tiles are in figure 50, you would be able to use that and come up with the answer.
Yes.
All right, what would you do for this?
I will multiply the. Oh, sorry.
Okay, let's Fatima talk for a minute. Okay, go
I
ahead.
will multiply the length with the width, like 5 times 6 plus 2, and then come up with the answer, which is 32.
Okay, Fatima, so instead of 5, what can we, if we don't know the number, what would we call it, like that length? Let's say you want to call the width something. What would be a variable you would use?
W, maybe.
Okay, you want to
or
use
X.
W? Go ahead, that's fine. You could use W. But what about the length? How much more than the W is the length?
1.
1. So you're going to do W times what? W plus 1?
Times 1.
So 1 is W, the other one is W plus 1, correct?
First, W times the length, and then plus 2. So
correct, but what would the length be in terms of the width? Isn't the length 1 more than the width?
Yes, it is more.
So instead of writing length, then you would write W plus 1, correct?
Well, let's first go by what Fatima is saying, Dr. Ramadan. She said 5 times 6.
Yeah, she was talking about the next shape,
and
but
then
we're
she
trying.
said add 2.
Right.
And
that's
Curtis
beautiful
knows
thinking.
that too.
That's beautiful thinking.
Right.
I was talking about the shade that we just did.
Oh, yeah, I got you, yeah.
And so, Curtis and Aja, and Anaya, are you following what Fatima is saying here? She's saying that if we use the analogy of my little kitchen exercise, she said multiply the 6, the length, times the 5, like getting area. And then she said those extra 2 tiles, add 2. And so that comes up with 5 times 6 is 30, plus the 2, 32. Would that work on figure 3? Curtis, could you do the same thing on figure 3?
Hey, Mr. Stone.
Fatima did?
Hey, Mr. Stone, we're going to go ahead and wrap up here so that we're able to discuss with the students. Sorry, I don't mean to cut you short, but if you want to go ahead and wrap up.
Well, I don't know if we can wrap up. When you say wrap up, I guess, do you want Dr. Ramadan to fully explain?
Well, I can't, you know what I was, when I was talking to Fatima, I was, so we have 5 is the width in that case. So what I was trying to get to Fatima is, let's call that 5W instead of calling it, it's just a generic number. And then I was getting into the length being 1 more than that width. And so we were trying to get to the expression. And then we will always add the 2 because there's 2 everywhere. So do you guys agree with that? Aja, Fatima? If you replace your 5 by W and your 6 by W plus 1, see what you can get out of that expression after that. Because really, part A was trying to get to a rule, and that's what we're trying to do here, is trying to get to a rule. See if that help us get to a rule. Okay.
Yeah, in other words, like Aja, you notice that it's added 6 from figure 1 to figure 2, added 8, and then added 10 continuously. So if we look at figure 1, there's 2. If we want to use the word length or horizontal across the rectangle portion. And then on figure 2, there's 3 going across. And then on figure 3,